Hello everyone, I am your educator Prachi, and today we are here to discuss about the topic acid, base and salt. So let us start. Acid. The term acid comes from a Latin term acre, which means sour. Okay, so we have to focus that the word comes from the Latin word acre, which means sour. And interestingly, all the acids also taste sour. Firstly used by Robert Boyle in 17th century. This word was firstly used by Robert Boyle in 17th century. So acid had many definitions, but what is the primary definition of acid? It is a substance which yields hydrogen ions when dissolved in water. Okay, when we dissolve acid in water, then what do we get? We get hydrogen ions. Here we can see that this is hydrochloric acid, and when we dissolve it in water, then what do we get? We get these H plus ions and these Cl minus ions. Okay, so point of importance here is that we are getting H plus ions, hence it is an acid. In our daily life we encounter many things which have acid in it. For example, in gastric juice which is inside our stomach, there is HCl. In soft drinks which we drink, they have carbonic acid. Ascorbic acid is present in lemon, oranges, and in lemon and oranges citric acid is also present. In vinegar, acetic acid is present. In tea, tannic acid is present. Okay, so these are the examples of common daily life things which also contain acid in them. There is a note. H plus ions in the water are very unstable. So when we dissolve acid in the water, we get H plus ions. But H plus ions as it is are very unstable. So they quickly react with the water and they form hydronium ions. So if somebody asks you that whether you will find H plus ions in an acidic solution or hydronium ions, your answer should be hydronium ions because H plus ions are very unstable. Okay. So this is a quick characteristics of acid. We will discuss this in detail as well. So what is a strong acid and what is a weak acid? You must have heard the word strong and weak in respect with acid. When an acid readily dissociates and produces more and more hydronium ions in aqueous solution, it means that it fully dissociates in the water. It fully dissociates and all of the ions are furnished in the water, then it is known as a strong acid. But when the acid partially dissociate and produce less hydronium ions, it means that the amount of acid is almost equal to the hydronium ions produced. This is a reversible reaction because acid is also there in the solution and the hydronium ions also there in solution, hence it is a weak acid. Okay, so this is a quick characteristic of acid. Now we will discuss about some characteristics of bases. What is a base? A substance which yields hydroxide ions when dissolved in water. So here what we are getting hydroxide ion or OH minus. This is a base. When we dissolve it in water, what do we get? We get an cation and an hydroxide ion. Okay. Here what we have to focus. Water soluble bases are known as alkali. Not all bases are water soluble. Okay. So the bases which are soluble in water are known as alkali. Few examples from our daily life which contain the basic substance is that sodium hydroxide or also known as caustic soda, it is present in soaps. Ammonium hydroxide which is used in hair dyes, and potassium hydroxide or potash is used in bathing soaps. Okay, so these are the examples of basic things in our daily life. Now let's discuss about salt. What is a salt? Salt are product of a neutralization reaction other than water. Now what is a neutralization reaction? When an acid reacts with a base, the resultant is a salt and water. So other than water, what do we get? We get salt. The most common example of the neutralization reaction is when we react hydrochloric acid with sodium hydroxide, then we get sodium chloride and water. Okay, so this is the salt. It is the common salt. There is a condition when we react strong acid with strong base, then we get neutral salt. That means it is neither an acid nor a base. When we react weak acid with strong base, we get basic salt. It means it is a salt, but it has somewhat inclination towards the basic pH. And what is pH we will discuss here. Strong acid plus weak acid, then we get acidic salt. So let us discuss the properties of acid in detail now. Properties of acid. So what is the taste of acid? It is sour. When we put acid on any indicator like litmus paper, then what happens? It turns the litmus red. Okay, so the acid turns the litmus red. Does acid conduct electricity? So here we can see, when acid dissociate in the water, they produce ions which help in conducting the electricity. As we have discussed earlier, that when acids are dissolved in water, they produce ions. So when ions are produced, then we can know that the electricity will be conducted. On the basis of extents of dissociation, strong acid and weak acid, we have discussed it. These are the example of strong acid: hydrochloric acid, hydrobromic acid, hydroiodic acid. And these are the example of weak acid like ethanoic acid. So the organic acids are always weak in nature. Okay, now let's discuss the next point, that is the reaction of acid with metal. When we will react an acid with metal, what will happen? We will get salt and hydrogen gas will evolve here. Okay, fifth point is reaction of acid with metal carbonate and hydrogen carbonate. If we will react the acid with either of metal carbonate or metal hydrogen carbonate, what will happen? We will get salt, water and CO2 in both the cases. Okay. Now when we will react the acid with metal oxide, then what will happen? When metal oxide will react with acid, it will again produce salt and water. Now when acid react with base, we have discussed that neutralization reaction occur and the salt and water will be formed. Now lastly, what is this corrosive nature of acid? Corrosive means when a object attacks something. Okay, the ability of acid to attack various substances like metal oxide. You must have seen when you put acid in any metal substance, the metal is start corrosion. That is known as the corrosive nature. It start deteriorating itself. The metal is deteriorated, so it is known as the corrosive nature. And it is not related to the strength of acid. You must not think that the strong acid will be more corrosive in nature or the weak acid will be less corrosive in nature. It just depends on the negative atoms present in the acid. For example, this fluoric acid, it is a organic acid and this is a weak acid. This is a weak acid, but it is a highly corrosive in nature. Okay, so now let's discuss about the properties of bases. Taste and touch of bases are, they taste bitter and they are soapy to touch. How does they affect indicators? They turn the litmus paper blue. The acid was turning it red and it is turning it blue. It also conducts electricity because, as we have discussed, it also produced iron, and when iron are produced, the electricity will be conducted. On the base of this, the bases are also two types, strong and weak. As I have mentioned earlier, that not all bases are dissolving in water. Okay, so the one which dissociate in water, they form ions and they are known as the strong acids. For example, this potassium hydroxide, when we put in water, it dissociates and produces potassium ions and hydroxide ions. Okay, cation and anion both. But weak acid are that which do not dissociate but react with water to furnish OH ions. For example, here when we dissolve this in water, it does not produce any ion. It reacts with water and forms a compound, and then that compound is releasing the ion. Okay, so this type of base are known as the weak bases. And how does they react with metals? They also react with metal in the same manner as the acid was reacting. Base plus metal gives salt plus hydrogen gas. Next property, when they react with non-metal oxide, they also produce salt plus water, and with acid they produce the salt which we have discussed, that is the neutralization reaction. Now let's discuss very important thing, that is the pH. What is a pH? It is the negative logarithm of hydrogen ion concentration. That means it defines the negative logarithm of the H plus concentration in a solution. The higher the pH, the lower the H plus ion concentration. Okay, you have to remember this. The higher the pH, for example, if the pH is 3 and if the pH is 5, then in which the more higher hydrogen concentration is present in the 3 pH. Okay, and it is more acidic, and the more hydrogen ion concentration, it means it is more acidic. Okay, so the less the pH, the more acidic the solution. The lower the pH, the more H plus concentration is there, and the more acidic the solution is. ठीक. Now the pH scale. It ranges from 0 to 14, where 7 is the neutral. It is a scale which defines the pH of the various solutions, and it is based on 0 to 14, where the 7 is the neutral. And in the pH scale, when something is less than 7, then it is acidic, and something is more than 7, then it is basic. Now what is pOH? As the pH was negative logarithm of H plus ions, the pOH is the negative logarithm of OH minus ion concentration. Here, the higher the pOH, the less the OH ion concentration. So in this case, when the solution has a pOH of higher than 7, then it is acidic, and when it is lower than 7, then it is basic. Okay, in both the cases 7 is the neutral. Here is a relation between pH plus pOH. pH and pOH has a relation. It means that pH plus pOH is equal to 14. Okay, so if any solution's pH is 1, you can easily obtain the pOH of the solution. Okay, that will be 13. You can easily obtain pH or pOH if one entity is known. It is at 25 degrees Celsius. It is notable. So this is the pH scale. pH scale. Here 7 is the neutral, and beyond it is basic solutions, and below this is the acidic solution. Okay, so this was a quick explanation of the acid, base, salt and pH concept. I hope you all understood it. Thank you very much.